this type of situation, especially these little drill presses. They're just not known to be the most accurate little things. So again, once I filled the column with concrete, I basically alleviated that problem with the flexing column. I then align my headstock permanently to this surface. Then I set my chuck so that it gives me the least amount of run out, and I had to literally find that position. Once I found that position, I epoxy it in place, and I brought the quill down to apply a little upward pressure, let it set. Now it's set for life. The only way I could take it off is probably to put a torch to it. The other problem that this small machine will present you with is this little slot right there. All drill presses have that slot, and there's usually a screw here that allows you to take up any slack, or say when you're using your lever, if you have a little looseness, you tighten this a little bit, and it also acts as a cheap way to lock the spindle. After numerous uses, of course, you develop some blemishes on the inside surface because these quills are just not made of very hard steel. In fact, they're not even hardened, I don't believe, because I was able to take it out and machine it elsewhere. And now I have rounded off the head of that screw slightly so it doesn't mar as much as it used to. In fact, it hardly mars it at all now. Another major modification that I did to it was to remove the little housing with the return spring that's usually located in this side. Now, there is a shaft that connects to the handle, passes through the headstock housing. That shaft has milled splines on it, then mate with the splines on the rack of splines on the quill, and as you rotate this, it causes the quill to rise up and down, so it's like a rack and pinion type device. Now, before I removed the spring, what I was doing was tightening the nut that held the little housing, and that tended to lock the spindle for a while until the housing started to deform. It became so deformed that I just decided to just take the whole thing off, and I went ahead and made myself a little handle. Now I'll take this off part way so you can see what this is like. I'll just take it off all the way since it may be hard to see otherwise. Okay, it's just a piece of aluminum turned on the lathe with an angle hole drill to it, piece of steel, and just a plastic ball handle. So a ball from an old vise handle. So this is the screw that comes through the whole unit. And as I said, what this does is just pulls against the handle and locks the whole thing in place. Once I took the spring off, I thought I would really miss it, but the truth of the matter is I haven't missed it at all in normal operation. So now I'm able to lock the spindle, and that in combination with locking on this side produces a relatively rigid situation here. So you just don't leave it loose, you have to lock it in both directions. This one pushes it that way, and this one also locks it in place. So now what I'll do is I'm going to show you a close-up of my dial here and take you through the various steps of that little puppy there. Let me focus on that. And you can see it very clearly. You can see the lines on it. Let me get back a little bit. This thing is not... Okay. So you can see the little witness mark is just a little file notch that I put on the pulley. The top has been machined, as I said before. So to change the adjustment, you just loosen this quill lock, and that allows you to rotate this to whatever setting you want it. So I was here before, so I'm going to rotate it to lower the quill 3 thousandths plus 5, that's equal to 8. Now to make sure that I've done that, I lower the quill till it clunks. That means it's in full contact with that pulley, and I tighten the lock, and I'm set to make my next cut. Now, talking about it is one thing, but I'm going to go ahead and set up a piece of stock in a few minutes and show you that indeed it does work. But before I do that, let me take you through this milling table here. This was one of those situations where I sort of was relatively lucky, as it was on sale by a major importer of Asian tools, one probably with not a very good reputation, but nevertheless, which gives you a pretty nice feel as you're sliding the X and Y slides. And not too bad for something that I didn't pay more than $75 on sale. They kill you on the shipping though. So, as I promised, let me go get a piece of stock and we'll chuck it to my little homemade vise. And let's just go ahead and take some surface cuts. With it, I'm going to mount the camera on the tripod and focus in close to the spindle. You won't see me, but you will see the work. So let's go ahead and do that next. Okay, I have set a piece of relatively rough sawn aluminum. This is your typical 6061 T6 aluminum, which is available practically anywhere. This particular piece, as with most of my material, was purchased at a scrapyard. It's a very affordable way of acquiring your supply of stock. Now I have already set this to give me a light cut, so I will loosen the lock, lower the quill, and lock it in place. Now we'll get my flathead screwdriver and lock the side screw. At this point, I will turn it on, and I have it set at about, maybe 550, and advancing the X dial, I will begin to take a pass. Now I have adjusted my Y feed so that only the top half of the cutter is actually cutting. That is, the part, or half of the diameter of the cutter, only half of the diameter, is doing the cutting. And that is the part that is rotating against my direction of feed. Now, advancing the X dial with both hands in order to control it and make sure that I am doing it as evenly as possible.